Now there is a slightly advanced one where you may need some more. See, for this method, we had these two, current terminals and potential terminals separately. Something like that, if you can bring for the whole bridge, then it may be possible. So that means you need additional wires. Then probably that can be realized. We will look into that also briefly, since we have spent this much. So let's say we have the full bridge here. This is INET. So this is what we discussed. Now I am saying, let's say from here, I draw one more wire. You treat this whole bridge as that RX.
So you are adding another wire.
Another two more wires. And I'm going to use, this will also have lead wire resistance. So it is RL3, RL4, let's say RL5, RL6. Looks like a mess now. But now, let's say I applied some Vs here and minus Vs here. What I wanted to ensure is that minus Vs is reaching here and plus Vs is reaching here. That's what we want.
And the two new wires, I just open it.
This is what we want. Okay, right? Now maybe I can use this to see whether it is really reaching there.
With a what's will reach?
I have this green wire now.
Yes.
To see whether am I getting minus Vs here.
Okay.
Same way, I can use this to test. Okay. Correct? Okay.
Yeah.
So now what we will do is, let's say Vs is given here. Right. And I will just connect to this. So if that is confusing,
And there's a feedback.
yeah. let's say for the students, it may be confusing. So we said this voltage follows a tree. And when we said, V naught is equal to Vs, whatever Vn, Vn. Now let's say I introduce some resistance here, RL1 or RL5. Some resistor is there, right? Will it matter? No, because there is no current flow this. Right? Now, let's say I introduce a resistor here. RL1. Even now, this voltage and this voltage are same.
So it's before there.
There is no current through this. So this is still V naught equal to Vs.
Okay.
Yes. Okay. So there may be some current flowing through this, which will come from the op-amp output. Op-amp output will be more than Vs.
Yes.
Because it has to take care of this drop also.
Oh, you're adding something.
Yes. So that way, I mean, I want Vs here, that is achieved through this. Correct? That's what we have done here. So you have Vs here. The one wire that was supposed to be Vs here, I was not sure whether it is reaching or not. I have connected it into the negative inverting terminal. So it's actually forming a voltage follower. Except RL1 and RL5 are part of this now. Right? Same thing we'll do for the other side. Minus Vs, and we will connect it to this. So the bridge actually has got plus or minus, it has got 2 Vs excitation voltage now. And that is assured because in the sense, earlier we have discussed about change in RL1, RL2, etc. Now it can happen. In the sense, I can vary this a bit. I can vary this. Still this will be Vs. Alright. Correct. As long as this voltage is within the operating range of this op-amp, we will have Vs here. So that way bridge voltage, which is 2 Vs now, is guaranteed. And anyway, this guy has solved the problem of loading. And current drawn through the RL3 and 4 are negligible. So all problems are solved.
Except the resistance.
In this case, that problem is not there.
What?
No, a resistance problem you means I into R naught, no?
Yeah.
Into 1 plus alpha t. Yeah. We are now no more relying on the, that's a good point. We are no more relying on the equivalent resistance of the bridge. In the sense, in this scheme, the bridge voltage was derived from I into equivalent resistance of this.
Yes.
That is how this R naught came into picture.
Yes. That.
In this, we are ensuring that, okay, this much voltage is there across the bridge.
Right.
Yes. It is not through, it is not by injecting current. Yeah, I understood. We started from this, where we are injecting current. Now, this was equivalent to that. But this is not by injecting current. We are ensuring that the voltage at the bridge is.
That means that voltage drop
across the bridge
will be the same.
Yes, irrespective of the temperature.
Right.
So it's as good as connecting source voltage there.
Yes. So lead wires do not matter.
Two lead wires. Only thing is, you have 4 plus 2, 6 wires. Yeah, but it solves the problem. Yes. It is. Yeah. Yeah.
Oh,
it could be in one cable with all these wires together.
So that solves the problem. solves all the problems.
Yes, sir. Yes. So this is, I mean, since lead wire can create a lot of, issues in the sense error in the output, it's good to know this technique. And also when we see measurement system here and the sensor is at the field, we may be thinking, how is it working without any problem? And what it shows is this simple electronics solves this problem in a very nice way. Yes. Yes.